Just need to check the lighting and the sound and this and that. And man, okay. Alright, so refactor Saturday at the end of our 7th week. I'm doing design patterns. All those katas and code are going to be available on GitHub for the last 7 weeks. And we are now deep diving into the game we made using just what we know. So factory pattern, strategy pattern, bridge pattern, command pattern, state pattern, and flyway pattern. We didn't actually start any of the phase 3 stuff yet, and I need to decide how this is going to work moving forward. The idea behind streaming for me was start working on my teaching chops, because one day in the far-flung future I would like to teach. And so I'm thinking about turning this into a kind of 8-week course that I stream, and then every 8 weeks doing these 6 design patterns applied to a new project, and then doing 2 weeks of deep dive, question answering, and all that. So we did a game this time, but it could be something different next time. I don't know what quite yet, right? But that'd be the idea. So I'm thinking about that now. 6 weeks of design patterns, 2 weeks of playing around, and then start back from the beginning. Hey, good morning there, Eshkatite. Good to see you. So, and the reason why I'm thinking about that is because as we look through our code, the game is fun. And honestly, anything that you make that is well made should be fun. There's a discipline in knowing when to step away as well. And my fear is that as we look at the complexity that this is gaining, that we'll start alienating people who are coming to learn right from a beginner series. And we don't want to do that. Or we don't want to have to make people wait until this game is finished, shipped, and in stores before they can hop on and start learning. So I'm thinking 8 weeks is probably going to be a good turnaround point to start over with a new project. Alright, so that being said, let's go ahead and dive into our game. So, when we left off last time was we changed the render, so we also got the items on the ground, and we added some items to our room. The problem is, in doing that, we introduced a bug where we lost our target, where we lost Carl, the zombie. So why don't we go in and see into our render. Let's go ahead and breakpoint there. We set the color as magenta. We want to write out targets in magenta. Then we set the color to dark green. And then we go to our monsters. We've got 0 monsters. So not necessarily a mistake, but how did we lose Carl? Let's go back over to our hive mind. So we are adding a zombie here. Go back over to our render. So we believe it's there. Let's speed up. Maybe we fat fingered something. So one of the last things we did was we went to monsters and we said, hey, give me all the monsters where the game state is also in play. Well, I guarantee you we did not set that as part of the monster factory. And the truth be told, we haven't done much in terms of state for the monsters. And as you can see, because we only have, one monster type. We can do that here. We can say game state, in play. So start in play. And so here's our monster factory. If you look at a monster, we're going off of iMonster for our interface. But we inherit from base monster. We go to that. And we're pulling base monster from base actor. And so our players also pull from base actor. So this is where the polymorphism really allows us to share certain characteristics and divert for other characteristics, behaviors, what have you. So we're able to really put some time and energy. If we look at just our base monster class, for example, super straightforward when compared to all the work we put into our player class to get all that rich functionality of classes, strategies, attacks, and heals, and all of that. So at some point we need to go back and put as much work into the monster class and all of that behavior. So let's try that again. And targets, monsters. Alright, now we have one. Because inside the monster factory we had said, okay, we instantiate this, go ahead and set that to true. And the default value of a Boolean is false. It starts in the off state, which I guess is safe. It'd be like a vacuum cleaner, right? When you plug it in, you want it to be off when you plug it in. And then you choose to turn it on. Okay. So we have our Carl here. So we're getting an extra line there, kind of not a huge deal, but just an extra little bit. We can copy pasta. That's up. Alright. Now we're looking good. Small little bugs, but we got our title for the room, we got our description, targets are Carl, also here would be all the players, and also non-player characters. So on the ground, test hammer, test gloves, charm, and we can fight Beth, we can look at Beth, we can heal Beth, look at Beth again, and Beth gets 11 because I healed her for 5 but hit her for 8. I can fight Beth, look Beth. Beth is out of play. So there's a few things here in terms of our messages. So Beth died. We don't actually get a death message because we don't really have a good way in the system to handle these this convergence of events or messages, right? We only have this one channel to output things to. Next week we might look at how we can handle that. If I do follow this kind of 8 weeks reset, we definitely in the 8 weeks want to get to a point where whatever we're doing is usable, and then with everything you've learned, you can start going in, playing around, extending, and you've got a nice jump point to go from. So that would be a cool thing to do. Alright, so I want to highlight something. If I do fight Wally, I'm going to get an exception, because we had a kind of a red flag here before. We always say we don't want to pre-optimize, because we don't always know where a bit of code is going. And so when you're optimizing, you're really removing flexibility a lot of the time. So you're really tailoring your algorithm and your method to do a very specific thing. This is why the the single responsibility principle is so important. You want a method to do one thing, or in terms of a higher level design pattern, you want it to handle one concept. If it's encapsulating kind of like a larger abstraction. But to keep it simple, we always want these things to do one thing and to be very specialized at that one thing. But until you know all the moving pieces of that one thing, it's hard to optimize. So, but here, we're seeing essentially the same code in all of these if statements. Else if, and I think this is a good way to show that refactoring or writing good code can be obvious, right? Because look at the things that change. Well, let's just look at the things that don't change, I think. We always get starts with, we always get the target name, we always get the target, we always execute against this the hive mind and pass in the player and the target and the game action. So then what does change? So fight seems to change, and then fight seems to change here for the game action. So we've got two things that change. So if we had a way, and I've shown this in other places where I use a map, and I love maps for this. If we had a way to abstract out finding those two things, we could replace all of this with pretty much one call. And then down here, this one's the same again. Plain old look is different. And so let's go ahead and just get all the ones that are the same kind of grouped together and see what we can do. Alright. So that's a lot of code to do essentially the same thing. And I wrote some boilerplate code at some point, I don't remember when I did it, to kind of handle this. So if we scroll down a bit, we should be able to see it. Okay. So, and I'm showing this mainly because I write things to get it out of my head, which is dangerous and beneficial at the same time. Because anything written by you 3 months ago might as well have been written by somebody else. In my case, anything I wrote yesterday, there's a good chance I will not remember why I put it down if it's not a complete thought. So, okay, I have a map, which is good. It's a dictionary that takes in a string and maps it to a game action of some kind. So this is also nice because you can have multiple things pointing at the same game action. So that gives us the ability to say, look, if you get fight or you get attack, go ahead and map that to fight. Right? Because so it's like this, it's a one-to-many relationship. So we've got our range and our domain. And this is just having this map gives a level of flexibility and just clarity here that's actually really hard to represent inside of a if-else statement. So you can say if the command starts with fight or the command starts with attack. Not horrible, but hopefully you can start to see how, well, if I did that 3 times here, and did that 3 times here, and 3 times here, and 3 times here, and 3 times here, I've got a lot of just noise that distracts from and makes it less evident that these things are really the same. So if you're coming into a project as like a new person, it ends up being really difficult if someone's got something like this that's really knotted to be able to see where you can refactor and optimize. So before it gets there, I like to kind of break things up. Alright, so there's my map. And that's it. So everything else is things we've done before. Get game action, get target. Oh, I'm sorry, maybe not. So here's the rest of my code. So this is actually all part of the same thing. So get game response. I abstracted out, and bear with me here.